even though I have my ladies up here, and I each gave them, or I have my 3 groups of students, and I each gave them 0, I still don't have any pencils. What if I had all 21 of you stand up here, and I gave you all 0 pencils? How many pencils would I have? Or would you have, I should say. Kaylin? 0. Go ahead and sit down, ladies. What's the multiplication equation that we use to figure out that last example with Natalie and Grace and Susie? What was that multiplication equation? Eva?
Groups of.
What? Read the whole equation for me.
Well, what was the multiplication equation that was
represented in our example? What's the equation that goes with what we just did?
How many pencils did...
I want a math equation, a number sentence, if you will. Aiden, do you know what I'm talking about? Go for it.
0 times...
Think about how you would say it.
0 groups of 0.
Did I have 0 groups?
What? 3 groups of 0.
I had 3. Alright, so Aiden, tell me that equation one more time.
3 groups of 0.
3 groups of 0. It's an equation, so we've got our equal sign equals.
Box question mark.
Well, we solved it.
0.
0. We had 3 students. They each had 0 pencils. How many pencils do they have? They have 0 pencils. Go ahead and write that equation down. And then as you're writing that equation, I want you to think about, why is the product 0? Why is the product of 3 times 0 0? Once you've figured out why the product is 0, I want you to write down some reasons underneath your equation as to why 3 times 0 is going to be 0. 0. Why would that be? Georgiana, what are you thinking?
Because anything groups of 0 is going to be 0. Because that's the rule of anything times 0.
Okay, rules have to have reasons. If I say, don't run in the hallway, that's the rule. That's true. But I want to know why. Yeah, in my example of running in the hallway, that's dangerous. You can fall, you can run into someone, you can run into something. Why is the product going to be 0? You're right, there is a rule, but I want to know why that rule is. Do you know what I'm saying? Tajir, what you think?
Because you're counting, the product is 0 because you aren't counting, because you're counting the 3 0 times.
Ooh, I like that. I'm counting 3 0 times. Count by 3 0 times. No. No.
Nothing. Nothing. 0.
If I tell you to do something 0 times, are you going to even try to do it?
No.
No. No. That's a good way to put that, Tajir. Counting zeros, or counting 3 0 times. What else were you thinking? Grace, what were you thinking?
The product is 0 because you didn't multiply anything. It's just doing 0.
I did not multiply by anything. Aiden, what were you thinking?
The answer is 0 because you have 3 groups.
Yep.
So if you had something else than 0, you would have to add that number 3 times.
Yep.
0 plus 0 plus 0 equals blank.
Yep. Beautiful. Beautiful. 0 plus 0 plus 0. If I'm doing my repeated addition, it's going to be 0. If you're looking at your equation, your 3, go ahead and add this to your notebook. Your 3 equals the number, that's a number sign. I know it looks like a hashtag. Before it was hashtag, it was number, I promise. Number of groups. You know that because when you read an equation, you say 3 groups. That first number is groups. Duh, we know that. This second number is the number of things in a group. So if we're doing our circles and dots, this would be the dots, the things inside the group. And then our product is how many things, that's supposed to be an S, total. Kind of like addition. How many things do we have in all? Well, if I have 0 things, how many things am I going to have all together? Parker? 0. 0. All right, let's generalize what we just did with this equation, and let's try another one. What about 5 times 0, or 5 groups of 0? What is that going to equal? Dylan? 0. 1 million times 0. What is that going to equal? Lucy? Does it matter if I have a million groups of nothing?
Yes, it doesn't matter.
No, because I still have nothing. I gave them nothing. 1 million groups of nothing is still nothing.
How do you even get groups?
Maybe I drew circles and then put nothing in them. What about 0 groups of 6? What about that equation? Ella Harris, what are you thinking? Do you think it's going to end up being 6?
No.
I have no groups of 6. What do you think? 0 groups of 6. Cord, what are you thinking? Table 3. Let me put it to you this way. I have 0 groups of $1 million. Do I have $1 million? No, I don't. That would be nice if I did, wouldn't it? Yeah. 0 groups. I still don't have anything. If I make my 0 group right here of 5 kids, how many kids do I have here?
0.
Table 0, table 1, table 2, table 3, table 4. I still have nothing. I still have nothing. Grace? I have, yep. They are still flying in space. I'm not correcting it. Just like in my 0 groups of $1 million, the dollars are still floating out in everybody's pockets. They're not mine yet because I haven't made them into a group. Or?
So you're saying everything times 0 is 0?
Everything times 0 is 0. Everything times 0 is 0. That's the rule that Georgiana gave us, and now we know why. Everything times 0 is 0. Even if I say tajir, multiply 10 times 7 times 82 times 58 times 0. It would still be 0. It would still be 0.
Like always numbers.
Alright, everything times 0 is 0. Add that to your notebook, please. Alright, remember when we used multiplication charts, we did this with the addition chart. Look in the top corner. It's going to tell you what operation. That X tells us that we are going to do what math operation? Cord? We're going to use multiplication. We're going to be multiplying. Now remember, the way it works is you put one finger on one factor, one part. So let's say I'm doing 2 times 5. I put one finger on the 2, one finger on the 5. And then where they meet is where the product is. You remember doing that?
Yes.
Yes. Alright, we are going to do our zeros. So let's put one finger on this 0 on the side. And one finger on the 0 on the top. 0 times 0 is what?
0.
0. Go ahead and write in a 0. Alright, let's move over. 1 times 0 is
0.
2 times 0 is
0.
3 times 0 is
0.
Go ahead and fill in the rest across the page because we know what the pattern is, we know what the rule is. Doesn't matter if we're multiplying by 0, that product is going to be 0. Multiplication chart.
Yes.
Go for it. What?
The top 0, everything under it.
Okay, so if I'm looking at my top 0 and I go down to my 1 over here, 0 times 1 is what, McKenna?
0.
0. Alright, let's keep going down. 0 times 2 is what?
0.
3 times 0?
0.
4 times 0?
0.
Huh. Our multiplication chart. Think about what those equations look like. Evan, what do you think?
Well, if you have like 5 times 0, then it's still going to be 0.
Okay, 5 times 0 equals 0.
But if you count 0 5 times, then that, if you count 0 5 times, then it's still going to be 0.
Sure, but we have 0 times 5 in our multiplication charts.
If you count 5 0 times, then it's going to equal 5.
Nope. Parker, what do you think?
Because you have to count 0 usually.
Okay, so what's 0 times 5? If I look at my multiplication chart and I say 2 times 0, is the product any different than saying 0 times 2?
No.
No. Remember when we first did addition and I said 1 plus 2 is still 3, just like 2 plus 1 is still 3. Multiplication and addition, it doesn't matter the order of my equation. For multiplication and addition, it does not matter the order. 2 times 0 is 0. 0 times 2 is 0. I can change my factors. That's what these are called. I can change my factors, and my answer does not change. McKenna? Yeah. Lucy?
But for taking words, you have to do it in a certain order because you have to put the biggest number first and then the lowest number last.
Very good. This is called the commutative property. Write that in your notebook. It's the name of the rule. You can put it underneath your multiplication chart, or you can put it on the same page that you did discovering zeros. I don't care. No. You have room on both those pages. So that's called the commutative property, where you can mix up. This is what you're writing, commutative property. You can mix up the order of the factors for multiplication, and your end product is not going to change. So if I had, let's do 0 times 6, that equals 0. 6 times 0, that equals 0. I can change the order in which I'm multiplying, and my answer doesn't change. The name of that rule that says you can do that is called commutative property. Yes. What's in red needs to be in your notebook, as well as the name of it, which is the commutative property, as well as the two equations in blue. Right, if we had 5 and we made it a fact family 2 and 3, 2 plus 3 is 5, 3 plus 2 is 5. Now Lucy brought up a good point. Addition has commutative property. Multiplication has commutative property. Does subtraction?
No.
No, because watch what happens if I was doing this fact family. 5 minus 3 equals
2.
2. Okay, what if I said 3 minus 5? That equals 2?
No. Yeah, minus 1.
No, that's going to give me like a negative amount.
Yeah.
It's going to be like less than 0.
Yeah.
So, does the order matter in subtraction?
Yes. Yes.
Yes. Does the order matter in multiplication?
No. It's going to be a double 0.
No. Well, yes and no. Does it matter for the answer?
Yes.
For multiplication?
No.
No. I can mix up my factors in multiplication and still get the same answer. I can mix up my add-ins when I'm doing addition and still get the same answer. Can I mix things up in subtraction?
No.
No. So does subtraction have commutative property?
No.
No. Make sure under your commutative property you write that it is only for multiplication and addition. Those are the only two things, two operations that have commutative property as a rule, which says you can kind of mix it up in any order and still get the same answer. Cord, what's that?
Can you have commutative property in addition? Ooh, good question. Google. Interesting question.
We'll save that question for when we dive into division. How about that, Cord? Because I don't want to blow your mind today. Okay? Parker, Cord, Jordana.
See, now all you
You do not need to run. My room has never been a track ever, and it does not plan to be. But you do gotta pay attention. Those of you looking out in space, you won't pay attention. I need 3 students up in the front of my room. This time I got Jordana, Cord, and Parker. Each student receives 1 pencil. Hold out your hands.
Yay, 1.
You're not keeping these in my pencils. Why they're a different color? How many pencils are there? Were there? How many pencils are there or were there, McKenna?
There are 3 pencils.
There are 3 pencils. What is going to be our multiplication equation? Oh, well, stop here. What's going to be my multiplication equation? Think about what are my groups? What did I give each of those groups?
1.
And what did we come up with? Raise your hand to tell me, Brian, what you thinking?
3 times 1.
We have 3 groups
Of 1.
of 1, and I said equation, so we need an equal sign. Yeah, 3 students holding 1 pencil each means a total of 3 pencils. Write that in your notebook.
You add 1 3 times.
You add 1 3 times, or you add 3 1 time. Product of 7 times 1 is going to be what, Dylan? 7. 7. Skip counted 1 time. 7. 7 groups of 1. 1, 2, 3, 4, 5, 6, 7.
Nice.
What about 1 times 9? What's going to be that equation? You need to make sure you have all of these equations written in your notebook. What is one group of 9 going to give me? Mason? Is what? Yes. So 9. 1 9 times is 9. What patterns do you think the 1 times table follows? I want you to write that down. I think the pattern of the 1's timetables is, and you'll finish this. Susie, what you thinking?
I think the pattern and the ones there's only one group of the number.
Okay, beautiful. There's going to only be one group of that number, depending on which the order is. Because if we look at 7 times 1, how many groups are there? There's going to be 7 groups.
Oh,
but only
1 times 7 is 7 groups of 1.
Yep. Aiden, what you thinking?
It always repeats itself.
What do you mean it always repeats itself?
So one group of 9, so you get one group of 9 which equals 9, and you get 7 groups of 1, so you do 1, 2, 3, 4, 5, 6, 7.
Okay, you want to add on that?
I think that the pattern in the 1's times table is that the sum is always the bigger number in the equation.
The product. Change that math word. But other than that, beautiful job. She said sum. Sum goes with what operation? Addition. Other than that, McKenna, beautiful. The product, read it to me again, the product.
I think that the pattern in the 1's times table is that the sum is always the bigger number in the product.
What's that equal?
0.
It's a good thought, McKenna, but this proves you wrong. Because what's the biggest number in that equation? 1. Is the answer to this equation 1?
No,
0.
No. That's a really good thought, though, McKenna. Really good thought.
when you have a 1 in the equation.
So I just have a 1 in the equation. 1 times 0.
It's a small number. There's no 0.
Cheyenne, what are you thinking?
I think the pattern in the 1's times table has a 1 in it. It's the same as the other number. Like, we would put it there.
Anything times 1 is itself. Anything times 1 is itself.
That's what I said.
That's pretty much what most of you said. Anything times 1 is itself. 7 times 1 is 7.
1 times 9.
1 times 9 is 9. Anything times 1
Is 9.
no.
I mean, everything times 1 is the answer that you got before.
No. Anything times 1 is itself.
Okay.
And that kind of helps clear up what McKenna was thinking. You were so close, McKenna. But if I do 1 times 0, well, anything times 1 is itself, which means 1 times 0 is going to be 0. Other than that, you were really super close, McKenna. I like it. So please make sure you have that written down in your notebook. Anything times 1, is itself. Can we fill in our multiplication chart with more facts? Yep. Turn back to it. Turn back to it. All right, what can I fill out now? Hey, we have some stuff filled out. Courtney?
On the 1s, we could do like 1 times 1 is 1.
Yeah, so if I do 1 times 1, anything times 1 is itself, so 1 times 1 is going to be 1. Let's go across. 2 times 1 is going to be
1.
No.
2.
2. 3 times 1 is going to be
3.
3. 4 times 1,
4.
keep going across.
start on the bottom going down?
Anything else I can do? Anything else I can do?
Yes.
Dylan, anything else I can do?
No, the one's gonna go down
Why?
because we go down to
Dylan thinks I can fill out a column going down. Why? For 2 bonus points. Why? Like magic. Gabriella, why?
It's because whenever you put a button with something else, sometimes if you do the multiplication, it contains its other opponent that it's going. It's like
Yep, we did that. We did that going across. I want to know why I can go up and down now. Parker, why?
going down because 1 times 2 is 1. And 1 times 3 is 1 times 3 is 2.
I know, we already did that. It's going across. Why? Natalie, why?
Because when we did the zeros, we went across and probably with the list of the to make a path. Because for most of them,
Why? Alan, why?
because if you go down, 1 times 0 is 1.
Elvira, why? You're getting closer. I got it. Chill. Why? Don't butt me, and I will not answer you. I'm not a dog. I know, I did my times by ones. I did that going across. Hayden?
because when you if you go down, it won't change because you're just going to be doing some things up here. Because anything times 1 equals
You were so close. You were so close. I did anything times 1 equals itself. I did that going across. Why can I also do it going down? You were so close, Ada. What do you think? What do you think, Ada?
because it's the same thing. The top and the bottom are the same.
Corey, what do you think?
Because there's other numbers on that side, so that means anything times 1 is that number.
I know, I did that going across. Why can I do it going down?
Numbers on the side, too.
So why can I do it going down? Why is it going to give me the same product? Mason, what do you think? Yeah. But I did that going across. Why can I do it going down?
And the multiplication chart
Guys, listen. I'm not even the speaker. You're not even being rude to me at this point. Mason's trying to explain what he thinks.
it was on the picture, so if you do the same numbers, it would make sense. Because if you go all the way down and across, go down,
I hear what you think.
Well, you can go down because when you go down, then you get different answers. And so if you don't finish,
I get different answers going down?
well, you get the same answers, but if you don't finish it, then the board, then it won't be done.
Let's see what you think.
Well, it's kind of like a array.
It is the commutative property. If I go across, I am doing 1 times 1, 2 times 1, 3 times 1, 4 times 1. If I go down, I am doing 2 times 1, 3 times. I'm flipping the order of the factors. Does it matter if I do 3 times 1 or 1 times 3? No. The product is going to be the same. I can go across and I can go down. Listen to what I'm saying. Because of the commutative property. Write that underneath your multiplication chart. You can go across and you can go down because of the commutative property. Somewhere where you have space. Underneath your multiplication chart to the side of, and then you can fill out the ones going down. You can do across and you can do down because of the commutative property. Talking.